Okay, welcome to 7.4, named the other trig functions, which is kind of a silly name, but here we are. And so we're going to start with a video that's nothing new. I know, shed a tear. It's not going to be that long, maybe. We've talked about all 6 trig functions before. We've talked about the unit circle before. So now let's just combine them, all right? So brief reminder of all of this stuff. So if we're looking at the unit circle, right? And again, just pretend that these are circles. Pretend that these things are balanced. We're looking at the unit circle. Maybe we have some point up here called x comma y. Well, then we can think of a triangle like so. Unit circle means the radius is 1. And it has an x coordinate and a y coordinate. Well, we used trig before to say, okay, well, the sine of t, think of this angle right here. Whoa. That's t. Well, then sine of t is the opposite over the hypotenuse, which is just y. We said the cosine of t was just x for the same reason, adjacent over hypotenuse. And then we said tangent is opposite over adjacent, y over x. It's also sine over cosine. Well, there are 3 more functions. The reciprocal functions. Don't forget about the reciprocal functions. The reciprocal of sine is cosecant. Reciprocal means it's going to be 1 over y. Reciprocal of cosine is secant. Reciprocal of x is 1 over x. And reciprocal of tangent is cotangent. Reciprocal is going to be x over y. And again, if we really want to be great math people, this is for all values except when y is 0. This is all values except for when x is 0. And this is also all values except when y equals 0. So this is the official thing that the book wants me to talk about. I'm going to be honest with you guys. I never think about this. Master's degree in math. Never think about this. Because as long as you remember these 3, you remember everything, right? If you just know sine and cosine and maybe tangent, well, the reciprocal functions are just the reciprocals. So you can have all these in your notes if you want, have them official. But these are the most important ones. And then just remember what reciprocal functions are, okay? Let's do an example kind of combining everything. Find all 6 trig function values. For t. So we're going to have t is an angle for a point on the unit circle. Maybe it's this point right here. And this is the point, root 3 over 2, comma 1/2. All we have to do is just go back to here. Sine is y, because we're on the unit circle. Cosine's x, because we're on the unit circle. So it's just writing a lot of things down. Sine, cosine, tangent, cosecant, secant, and tangent. So I'd recommend pausing the video now and filling these in. Pause me. All right. Hopefully this is what you filled in. On the unit circle, sine is y. What's the y value? 1/2. On the unit circle, cosine's x. That's root 3 over 2. Tangent's a little bit more complicated. Let's go to the side. Tangent is y over x. So it's 1/2 divided by root 3 over 2. But that has to simplify. Right? That's 1/2 times the reciprocal, 2 over root 3. Dividing by a fraction is the same as multiplying by the reciprocal. And the 2's cancel. We're going to get 1 over root 3. And again, the book rationalizes this to square root of 3 over 3. But you don't have to rationalize the denominator. You can if you want. And then the rest are just the reciprocals. So the reciprocal of 1/2 is 2. The reciprocal of the other one is 2 over root 3. But again, the book would write this as 2 root 3 over 3. But you don't have to write it that way. You can if you want. And the reciprocal of 1 over root 3 is just the square root of 3. All right, so notice, by the way, when I did this problem, I didn't use those formulas at all, right? I just used these and then took the reciprocal. You can do the same thing. Let's do one more example, and then this video is going to be over. Example 2. Given the sine of 45 degrees equals square root of 2 over 2, and again, that's the same as 1 over the square root of 2. Given this, and given that cosine of 45 degrees is the same thing, find the tangent of 45 degrees and the cosecant of 45 degrees. Let's go back to the previous page, just one moment. As a side note, I hinted at it earlier, but it's really useful. I don't know where I'm going to fit this. If tangent's y over x, another way of thinking of tangent is tangent sine, which is y, over cosine, which is x. This is useful. And we're going to use this often. Notably, right now. Okay? So tangent of 45 degrees is the sine of 45 degrees divided by the cosine of 45 degrees. Well, sine and cosine are the same thing. It's equal to 1, right? Root 2 over 2 divided by root 2 over 2. That's the same thing. Cancels out completely. They are the same thing. Tangent of 45 degrees is 1. And the cosecant of 45 degrees, right? That's the reciprocal function for sine. Now this one has a little bit more algebra. There's two ways of doing this. You can either plug this in and simplify, or say reciprocal just means flip it upside down. 2 over the square root of 2. Why is this not my final answer? The reason why is because it's not simplified. Okay? All right, this can simplify. This can simplify, okay? That was weird. Because square root of 2, like 2 is just the square root of 2 times the square root of 2. Right? This is just equal to positive 2. But one of the square roots of 2 are going to cancel. And we just have the square root of 2 right here. There we go. We're done. Happy face. Or maybe sad face. Maybe you don't want to be done with this video. But either way, it's over.